Hello friends, welcome to Abednego Online Math. We are asked to solve or prove that x raised to power y is equals to y raised to power x. So what we're going to do is, let y equals to kx, and k is a constant. So if we have that, we can also express this as x raised to power kx equals to kx raised to power x, since we say let y equals to kx. So if y equals to kx, and we can now say let us square root both sides. So if we square root both sides, we are going to have the square root of x raised to power kx equals to the square root of kx raised to power x. So if we have that, we can express this square root in form of x raised to power kx raised to power 1 over 2, that's square root, equals to kx raised to power x raised to power square root 1 over 2. So if we have that, if we multiply now, we're going to have x raised to power kx divided by 2 equals to kx raised to power x divided by 2. So that is what we have. Let us multiply both sides, that is the power, by 2 over x. So if we multiply the power both sides by 2 over x, this is what we are going to have now. We're going to have, if we multiply the power both sides by 2 over x, we're going to have x raised to power kx divided by 2 times 2 over x equals to kx raised to power x over 2 times 2 over x. So if that happens, this will go with this, and this will go with this. Then this will go with this, and this will go with this. So what are we going to have now? We're going to have x raised to power k equals to kx. So if that be the case now, we can say let us divide both sides. Let us divide both sides now. Divide both sides by x. So if we divide both sides by x, we are going to have x. We're going to have x, or let's say we divide both sides by x, we're going to have, see what we're going to have now. X raised to power k divided by x equals to kx divided by what? X. So if that be the case now, what are we going to have in total? What are we going to have in total? We're going to have x raised to power k minus 1, because the power here is 1 from the rules of indices now. So we're going to subtract, equals to k, because this will cancel this. That is what we have. Now if we have that, we can multiply both sides now by, let's say 1 over k minus 1. So if we're going to have that, we're going to have x raised to power k minus 1, that is the power now, multiplied by 1 over k minus 1. 1 over k minus 1 equals to k raised to power 1 over k minus 1. So if we have that, this 1 over k minus 1, this will cancel this. what is remaining is x. What is remaining is x equals to k raised to power 1 over k minus 1. That is what we have now. So if we have that result now, we can call this, let's say, equation 1. So if I have that equation 1, I can now say then this implies that y is equals to, we know that our y is equals to kx from what we say, let y equals to kx. So if y equals to kx, it therefore means that if we substitute the value of k now, we are going to have, if we substitute the value of k, we are going to have, this implies that y is equals to k into k raised to power 1 over k minus 1. That is what we have, minus 1. So if that becomes the case, it therefore means that y is equals to k raised to power 1 plus, because this, the power here is 1 plus 1 over k minus 1. So that is what we have there. Then if we have that result, it means that y is equals to k raised to power k minus 1 plus 1, then divided by k minus 1. So if we do this now, so y finally becomes, this implies that y equals to k raised to power k divided by k minus 1. That is it. So if that be the case now, y becomes k raised to power k divided by k minus 1. That is what we have. And we know that our k is a constant. Our k is a constant. So since k is a constant, we can now say if, let's say we assume if k equals to 3. So if k equals to 3, what does it mean? It means that our x equals to k raised to power 1 over k minus 1 from what we got here. Where is it? From what we got here, x equals to 1 over k minus 1. Therefore means that x will be equals to 3 raised to power 1 over 3 minus 1. And the answer will become 3 raised to power 1 over 2. And which is equals to the square root of 3. That is equals to the square root of 3. So if that be the case, it therefore means that y already is equals to k raised to power k divided by k minus 1. K raised to power k divided by k minus 1. It therefore means that since our y is equals to that power, it therefore means that we can rewrite this as y equals to, what would that y now be? Equals to 3, since k is 3, we say let k be 3 divided by 3 minus 1 equals to 3 raised to power 3 over 2. And we change it to root form, we're going to have the square root of 3 raised to power 3. The square root of 3 raised to power 3. So if that be the case now, but our x from original equation raised to power y is equals to y raised to power x. So if we now substitute the two values now, we're going to have the square root of 3 raised to power y is root 3 raised to power 3 will now be equals to square root raised to power 3 or raised to power square root of what? 3. So if that be the case now, we can also rewrite this. After rearranging, we're going to have cube root of 3 raised to power 3 over 2 equals to cube root of 3 raised to power 3 raised to power 3 here raised to power 3 raised to power 3 over 2. So if we now compare, now we have cube root here, we have cube root here. Since we have cube root there, we have cube root, then 3 raised to power 3 over 2, 3 raised to power 3 over 2. We now say that left hand side, the left hand side is equal to the right hand side. That's to say, we have been able to prove that equation, that the equation is correct. But already we have the values of x and y already. So our value of x is square root of 3 and our value of y is square root of 3 raised to power 3. So I've been able to prove that our answer and result is correct. Thank you for watching, and do remember to subscribe. If you have a different opinion and answers to this question, drop it in the comment section. Thank you.